All right, we're ready. Okay, we are looking today at more triangles, and I want to talk a little bit about where we've come from since we've started our journey. Now, the last several days we have been dealing with law of sines. Now, does anybody remember why we needed law of sines? Why, while we were going along with sine, cosine, tangent, and their buddies, cotangent, secant, cosecant, why did we need law of sines? Why wasn't that good enough anymore? Why did we need to use law of sines? Okay, what about the triangle? They're not right triangles. Law of sines is what we deal, it is how we deal in situations that they are not right triangles. Now, there are several situations where we use law of sines. What situations were they? When did we use law of sines? What? When did we use law of sines? Angle, angle, side. Absolutely. Angle, angle, side, we're going to use law of sines. When else? Angle, side, angle, we're going to use law of sines. When else? Side, side, angle, we're going to use law of sines. Now, let's remember our geometry. If I am looking at a situation with angle, angle, side, that means I'm given an angle, another angle, and then a side. Now, why, when I'm given an angle, and another side, why can I use the law of sines? Why will law of sines be okay in this situation? Well, if I set up law of sines, is it going to work in this situation with a triangle like this? Is law of sines going to work if I set up law of sines with a triangle that looks like this? Yeah, why? Okay, there's not a right angle. What else? We're going to have one complete pair, right? I am going to have one fraction that's full. I have an angle and the side across from it. All right, now let's take a look at angle, side, angle. An angle, then a side, and then another angle. Is this going to work with law of sines? Why? All right, first of all, we got some work to do. We've got to find that third angle, but then once I find that third angle, I have an angle and the side across from it. I'm going to have an angle and the side across from it. All right. What about side, side angle? All right. I know a side, another side, and then an angle. Is that going to work with law of cosines? Yes, it definitely works with law of sines because of what? Because I have an angle and the side across from it. We need, when we are doing law of sines, when you are doing law of sines, you need an angle and the side opposite. Okay, now there are two other situations that we need to have a discussion about. The two situations that we need to have a discussion about today are side, angle, side, and side, side, side. Okay, let's look at side, angle, side. Side, angle, side, I got a side, then I have an angle, and then I have another side. Is this going to work for law of sines? Why not? There's not one pair. Can I find this angle? I mean, this angles, I don't have two angles. I can't find two angles. I can't find a side. I don't know how to find a side. I don't have an angle and the side across from it. I don't have one full pair. This is not going to work for law of sines. All right, what about side, side, side? Same thing. I don't know an angle and the side across from it. I don't have one full pair, which means that I need something else. And the something else that we are going to be needing and that we are going to be using is called the law of cosines. Because I do not have an angle and the side across from it, I need law of cosines. Okay, so here we go with law of cosines. All right, law of cosines looks like this. Law of cosines is another situation where it is not a right triangle. We want to use the law of cosines only in situations where they're not right triangles. Now, law of sines and law of cosines actually work in right triangles. It's just, boy, it's a whole lot easier if we just use a regular sine, cosine, tangent and their buddies. So we really need it in situations that they're not right triangles. Okay, now law of cosines looks like this. It's a little bit messier than the law of sines. A little bit messier than the law of sines. Law of cosines looks like this. If I'm looking for little side A, I'm going to start out with little side A squared equal to little side A squared equal to my other two sides. So that's going to be B squared plus C squared minus 2 times the other two sides, which are B times C, times the cosine of the angle that matches the side on this side. So it's going to be cosine of angle A to match little a on the other side. Boy, I sure would be writing this down. All right, so that helps me to find little a. All right, now if I wanted to find little b squared would be equal to my other two sides squared. Now, Natasha, what are my other two sides squared going to be? A squared plus C squared minus 2 times my other two sides, which are AC, times the cosine of angle B that matches little b on that other side. All right, Miss Maddie, if we're looking for little c, can you tell me what my formula is going to look like?
C squared.
Little c squared equal to beautiful. Beautiful. So, 3 different formulas, but really it's the same pattern for each of them. Does that make sense? It's the same pattern for each of them. Okay, now, here's the deal. Here's the deal. When do we use the law of cosines? Okay, we're going to use the law of cosines in 2 situations, and we just talked about them. What were they? Side, 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 and? Side, angle, side. Very nice. We're going to use it in side, angle, side, and we're going to use it for side, side, side. Side, angle, side, and side, side, side. Okay, let's say we're in a side, angle, side situation. Okay, side, angle, side. I want to find my last side. Okay, I want to find my last side first. So we're going to find the side opposite the given angle. And we have to use the law of cosines. We have to use the law of cosines to get that started. We're going to find the side opposite the angle that we are given. All right. Then this one's a little bit tricky. Now, once I know that angle, once I know that side, I'm going to know a pair. I'm going to know an angle and the side opposite it. So what am I going to use once I know an angle and the side opposite? I can use the law of sines then, right? Once I know an angle and the side opposite, I can use the law of sines. Now, I'm going to use the law of sines, but I have to be very careful. When I use that law of sines, I need to make sure that I find the smallest angle in the triangle. And the reason that I need to make sure that I find the smallest angle is so that I make sure that that angle is not going to be an obtuse angle. I want to find an angle that's not going to be bigger than 90. I want to find an angle that I know is not going to be bigger than 90. All right? And then last but not least, I'm going to find the third angle. All right. Let's say that I'm in a side-side-side situation. Obviously, to get started, I got to find an angle. I've got to be very picky, though. I want to make sure that I find the largest angle. I want to find the largest angle, and I have to use the law of cosines. The law of cosines will find an angle that's obtuse. The law of cosines will find an angle that's obtuse. It's a little bit magical. So if it's the largest angle, it's going to find that angle if it's obtuse or if it's acute. Then I'm going to use the law of sines to find the second angle. And how do I finish up? What's the last thing I'm going to do? What is it that I'm missing? I got to find the third angle. I got to find that last angle. All right, are we okay with that? Questions, comments, concerns? Okay. All right, let's go to example number 4. All right, I'm going to start out with example number 4. I'll write this on a separate sheet. Example number 4. We're going to solve triangle ABC with angle B 81 degrees, little a 22, and little c 19. Making sure we got plenty of room. Okay, all right. Any thoughts on what we're going to do first? Jack, what do you think we should do first?
We should draw the triangle.
Yeah, let's draw a picture. Let's see what it looks like. Let's see what it looks like. So I'm going to take triangle ABC. Little a is across from angle A, little b is across from angle B, little c is across from angle C. All right, they tell me angle B is 81 degrees. They tell me little a is 22. And they tell me that little c is 19. All right, what are you thinking next? What are you thinking next? Brandon, what are you thinking? All right, what scenario are we in here? Absolutely. What situation did they give me? And Brandon, what situation did they give me here? Side, angle, side. Very nice. They gave me a side, then an angle, and then another side. Side, angle, side. Okay, now, when it's side, angle, side, Tyler, when it's side, angle, side, what's the first thing I've got to find? You bet. We're going to find our last side. We're going to find that third side. Now, which side is going to be the side I'm looking for, Megan? Little b. Okay, so if I'm looking for little b, Megan, can you help me write what formula that I'm going to use? Beautiful. Little a squared plus little c squared minus 2ac cosine of angle B helps me to find little b because it's equal to little b squared. I love it. All right. Now, Shia, can you help me fill in what I know? What? Okay, so I got little b squared is equal to little a, so that's 22 squared plus 19 squared, subtract 2 times a, which is 22, times c, which is 19, times the cosine of b, which is 81. Very nice. All right, time to get out our calculators, watching the magic. All right, this should be one set of keystrokes in your calculator. We should be able to do 22 squared plus 19 squared minus 2 times 22 times 19 times the cosine 81 and watch the magic. It's going to be better than Disney. Having a magical day. Yvonne, what are you thinking? 714.22 is equal to what? B squared. Very nice. 714.22 is equal to b squared. All right. Now, Braden, what do we have to do from there? Beautiful. We're going to square root both sides. So what do you get? 26.7. All right. We're going to round the sides. Let's be consistent. Round the sides to the nearest tenth. 26.7 is equal to b. Now I got a question. Mathematically, I did something wrong, or I forgot to do something. What do we need to do when we square up both sides? Plus or minus. Now, once I see that plus or minus 26.7, what am I thinking? Yeah, it's only going to be positive 26.7 because it's the side. But don't forget that. It's when we do it sometimes and we don't do it other times that we forget it when we need it. Anytime you square up both sides, make sure you do plus or minus. So, little b is 26.7. All right, fantastic. Now, as we're looking at that, how does that look? It looks pretty good. What looks better right now than it did before? Why does this look better right now than it did before? All right, we've got a pair. I have an angle and the side across from it. I have an angle and the side across from it. So that tells me that I can set up what? Law of sines. I can set up the law of sines. All right, Ian, tell me what the law of sines is going to look like in this problem. Beautiful. All right, now, once I set up this law of sines, in this situation, does it direct me to telling me what I need to find next? The algorithm or the process that we talked about, does it lead me into what I should find next? What did it tell me? Side, angle, side. I had to find the last side and then what? Which one did I need to find next? Take a look back. The smallest angle. Now let's take a look. In this triangle, which angle is going to be the smallest? C. How do we know that? It's across from the smallest side. So I've got to find the smallest angle, which in this case is going to be angle C. So when I look at this, pretty excited because I see this fraction that has both pieces, and it's equal to this fraction that I'm looking for C that's only missing 1. So I have the sine of 81 over 26.7 is equal to the sine of angle C over 19. All right, Nick, tell me what we're going to do there to find angle C.
19 times sine 81 divided by sine 26.7.
Okay, I like your thinking. Let's slow her back there a second. So we got to cross multiply. So 19 times the sine of 81 is equal to what?
Sine 19 times sine 81 equals 26.7 sine C.
Times the sine of C. Beautiful. And then what did you say we needed to do to get angle C?
Divide by sine 26.7.
Okay, careful. What are we going to divide by?
26 sine.
Just by the 26.7, right?
Oh, you know, it's
Nope, the sine is attached to that angle C, so I'm just going to divide by that 26.7. And then I get that the sine of C is equal to, all right, what do we got there? Take our calculators, what's 19 times the sine of 81, and then divided by 26.7. Kiara, do you have that one? Whoa, 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 0.7. All right, 0.7028. All right, so my angle C then is 0.7028.
Tiniest little angle.
Wow, he's a little critter.
Just inverse.
Natasha? That's right. I need to find the angle. Right now that's the sine of the angle. And like Natasha said, to find the angle I have to do the inverse. So I'm going to do the inverse sine on both sides. So how much does angle C actually end up to be? We're going to take our angle to the nearest degree. 44.5, right? So what does that become? 45. To the nearest degree for our angle. All right, so I'm going back up here to my picture, and angle C, I've got 45 degrees. Perfect. Done, Jack?
No,
Why not?
we still have to find the angle for A.
And how do I find that third angle?
Use the north side.
I could. Do I have to go through all that work?
Oh, no, you would just add up 45 and you would take it away from 1A.
Beautiful. I'm going to find angle A by taking 180 and I'm subtracting the other two angles. Beautiful. So how much do we get for measure of angle A? 54 degrees. Beautiful. And I have solved this triangle because I know all the sides and I know all the angles. Perfect. Fun or what? A lot of fun. We like to substitute that word work for fun. Yeah, that's okay. Sometimes we forget. We get so wrapped up we don't even know we're having fun anymore. All right, let's try another one. We're going to go right down to example number 5. I know we're pumped up about this. All right, in example number 5, we're going to solve triangle ABC with little a of 8, little b of 12, and little c of 10. All right, let's see here. Brandon, what are we going to do first? Beautiful, I'm going to draw that triangle. All right. Triangle A, B, C, little a across from angle A, little b across from angle B, little c across from angle C. All right, what do we have in this triangle? Maddie, what did they give us in this situation? Little a is 8, little b is 12, Little c is 10. Perfect. All right. So what is the first question that I'm asking myself, Miss Leah? What kind of situation do we have? Absolutely. What situation are we given? Side, side, side. All right. Now, can I use law of sines? Why not? We don't.
Oh, no, there's no pair.
There's no pair. There's no angle in the side across from it. I can't use law of sines. That's a bummer because I love law of sines. All right. But that means I have to use the law of cosines. And if I use the law of cosines, what is the first thing I'm going to say? What am I going to find? I'm going to find the largest angle.
No matter what,
No matter what.
even if they ask you to find a different angle,
Well, if they ask me to find a particular angle, I can use law of cosines to find any of those angles. But if I'm going to solve the triangle, I want to make sure that I find the largest angle first. Is that fair enough? All right. Now, which angle is going to be my largest angle? Little b. Angle B. Why is angle B going to be the biggest angle? Yeah, because it's across from the biggest side. So it's going to be angle B. All right. If I'm trying to find angle B, Shia, what is the equation that I set up going to look like? What? Okay, so we got little b squared equal to little a squared, little c squared, beautiful. Little b squared equals little a squared plus little c squared minus 2ac cosine of b. Absolutely love it. Fantastic. All right. Ian, help me substitute the values in there that I know. What? What? I didn't hear you. I'm sorry. Are you sure? What is little b? 12 squared is equal to 8 squared beautiful. Very nice. All right, Kiara, what are we going to do first in there? All right, tell me what I'm doing to solve. Okay, tell me, yeah, 12 squared is what? 144, yeah, equals 64 plus 10 squared is 100. 160, and then the cosine of b. Beautiful, beautiful, beautiful. All right, anybody have any thoughts about what we want to do next? Add the like terms. I like that. I like that, add the like terms. Now, Jack, I'm going to come back to you. Which terms are like terms then? What are you putting together?
Oh, that wasn't true.
No, I was.
The 64, the 100, and the 160.
Okay, so the 64 plus the 100 minus the 160. I'm seeing yeses, head shakes. I'm seeing not so much head shakes. Natasha's not happy.
Isn't the 160 connected to the cosine?
Oh yeah, is the 160 attached to that cosine of b? Can I break them apart? They're attached by what? Multiplying. What's the only way to undo multiplying? Dividing. Am I dividing? Nope. We're not going to put him together. But I love the idea of putting the 64 and the 100 together. So 64 together with 100 is 164 minus 160 cosine of B. All right, now what? Subtract 164 from both sides. Beautiful. 144 take away 164 is negative 20 is equal to those cancel. Negative 160 cosine of B. Things are looking fantastic. Tyler, can you take it from there? Very nice. We're multiplying by negative 160, so now I'm going to divide both sides by negative 160. So my negative 160s are going to cancel, and cosine of B is equal to, what do we get? Negative 20 divided by negative 160. 0.125. Anybody know what that really is? 0.125? 1/8. Very nice. As a fraction, that's 1/8. Now, does that mean that my angle then is 0.125? Oh yeah, inverse what though? Beautiful. The cosine of my angle is 0.125. So to find the angle, to undo the cosine, I'm going to do inverse cosine. And what do we get for that angle B? 83 degrees when we round to the nearest degree. So angle B is 83 degrees. Now, does that make you happy? Why? Now, why can we use law of sines? Because we have a pair. We have an angle and the side across from it. I have a full pair. So I know that I can go right to the law of sines. All right, Shia, set up that law of sines for me, sir. A. Beautiful. Is equal to? Beautiful. Nice. Very nice. Over 10. Very nice. Now, boy, I love this. Looking great. I see that I have one full pair, so I have one full fraction. One fraction that can help me find something else. Now, at this point, does it matter which angle I find next? No. Nope, it doesn't, because I already found my angle if it was obtuse. So I don't need to worry about that. Okay, so with that said, which one do you want to find? C. I heard C. All right, it's all about Yvonne. He wants to find C. Perfect. So we've got this sine of 83 over 12 is equal to the sine of C over 10. All right, Yvonne, your way, you tell me what to do. Cross multiply. Tell me what to write. 10 times the sine of 83 12 times the sine of C. Fantastic. Where are you going to go from there?
Divide by 12.
Divide both sides by 12. So what did you get for the sine of C? All right. Do we agree with that? 0.83? 0.8271? Is that what we got? Double check it. Okay. 0.8271. Is that my angle C? Nope. What do I have to do? Find the inverse sine. All right. So what do we find for angle C? All right. Angle C, we're going to get about 56 degrees. I like that. So angle C is back up here. It's 56 degrees. All right. Done? Why not? I've got to find that third angle. And how do I find that third angle? All right, so to find angle A, I'm going to do 180, subtract the other two, which is 83, subtract 56, and how much is angle A? 41 degrees. So I'm going to come back up, and I'm going to make angle A 41 degrees. I'm good. I found every angle. I found every side. Any questions with that? Okay.